Well, welcome back. We're going to try something a little different today as we're entering into Chapter 8. We're doing Section 8.1 today, modeling inverse and joint variations. And we're going to try to do this on my iPad, so we'll see how this goes. I hope it can do some kind of cool things. If I got it in the right mode, I can flip the page upside down, make it big, make it small, and scroll through. So I think it's going to give me some other options with what I'm doing here. So I'm hoping it'll work well for us. Inverse variations. Inverse variations. Really, when we're talking about inverse variations, we're talking about an equation. Sorry. Let's try that again. When we're talking about inverse variations, we're talking about an equation like y equals a over x. And what I think about y equals a over x, I'm generally thinking about, in my brain anyways, bricks on a wall. And I think if I put really big bricks on a wall, I won't need very many of them. And that's an inverse variation. And if I use really small bricks, I need a lot of them. So as the size of the bricks goes up, the number of bricks that I need goes down. And so that's an inverse variation. When one thing goes up and another thing goes down. The constant of variation in this situation would be a. That's always going to be the same number. And if I'm thinking about something having a joint variation, it could be direct, it could be inverse. A joint variation is generally something like y equals a zx or something. It varies jointly with these two things, and we'll talk about that more in a little bit. So, as I said earlier, y equals a over x is the constant of variation, and the constant a is the constant of variation, and y is said to vary inversely with x. So right there you would write vary inversely. I think I spelled that right. Well, vary inversely with x. Tell whether x and y show direct variation, inverse variation, or neither. Direct variation, when we talk about direct variation, we're talking about things like the more hours I work, the more money I get paid. So if I work more hours, then my money goes up. So when I look at this thing, is this direct or indirect? Well, I solve for y, so I have y equals, and I multiply both sides by 9x, and that to me looks like a direct variation. Direct variation. And xy equals 3. Now if I divide by x, I get y equals 3 over x, and that right there is an inverse variation. Alright, so you guys take a look at that checkpoint. Go ahead and pause for 30 seconds and go through it. Okay, this one right here, number 1, I hope you put neither. That does not, when you're adding and subtracting, that's neither direct or indirect or inverse. This one right here, after you solved it, I hope you got an inverse. And this one right here, after you multiply by 2.6, I hope you saw a direct. Next page of notes here on example 2. The variables x and y vary inversely, and y equals 3 when x equals 6. Write an equation that relates x and y. Find y when x equals negative 9. So if it says they vary inversely, right away I write that equation. Y equals a over x. I guess the one benefit I have, I can make this a little bigger on our screen here. Y equals a over x. And so if it gives me a y of 3 and it gives me an x of 6, I can find what a is. And that's really what you're always trying to do, is find that a, that constant variation. So if I multiply both sides by 6 here, I get that a equals 18. So my equation becomes y equals 18 over x. So when x is negative 9, I got 18 over negative 9. Therefore, when x is negative 9, y is negative 2. That's how you find that. You go ahead and take a look at that checkpoint, see how you do on that. I'll give you, take yourself about a minute or so. All right, welcome back. The variables x and y vary inversely, so right away I hope you all wrote y equals a over x. And y is 4.4 when x is 5, so a over 5. Write an equation that relates x and y, and then find the a. So first, to write the equation, you multiply both sides by 5. 4.4 times 5 is 22, so a equals 22. My equation is then going to be y equals 22 over x. Find y when x is 8. Well, I put 8 in there for x, and I get y equals 22 over 8, which ends up being 22 over 8, which ends up being 11 over 4. So it's 11/4, or maybe you had 2 and 2.75, something like that. So let's take a look at example 3. On example 3 here, determine whether m and n show inverse variation. The one rule that we have to find inverse variation is kind of slick. You just take all the numbers and you multiply them. If you take the x and the y, or the m and the n in this situation, and you multiply them, well, you'll notice when I multiply all these out, I get 225 every time. Well, if when I multiply the two things, I get the same answer every time, I know that if each one's equal to 225, so the data must vary, or they have here, so the data do show. Can you imagine saying the words do show? I don't know if I've ever said that before. Inverse variation. A model relating m and n is m times n equals 225, or n equals 225 divided by m, which is an inverse variation. The value of n when m is 45, you see up here I don't have 45, right? I don't have that additional piece. So n equals 225 divided by 45, and that's going to be 5. All right, let's take a look at the next page. Okay, you guys go ahead and take a look at this. Take a few moments, work it out, and see if you think it is or it isn't. All right, I hope right away what you guys did is said 2 times that is 36. 2 times 18 is 36. 4 times 9 is 36. 6 times 6 is 36. 8 times 4.5. Guess what that one is? Yes, 36. And 10 times 3.6 is 36. A lot of 36s, yes. Answer is yes. And the constant variation just happens to be that 36. So it's y equals 36 over x. Now, joint variation occurs when a quantity varies directly with the product of two or more, watch this, here's the great thing about this thing. Let's make it so big that I can make my more fit right there. More, there you go. And then I'll take it back, go, there it goes. 2 or more other quantities in the equation below. A is a non-zero constant, so you might have something like z equals axy. Z varies jointly with x and y, and that's referring as a direct variation when it says the word jointly. All right, so let's take a look at example 4 here. In example 4, the variable z varies jointly with x and y, so right away, z equals axy. Let me make this a little bigger so it fits on my page a little better. Z equals axy, and then when z is negative 84, so I can put negative 84 right here, and x is negative 4 right here, and y is 3, and really you're trying to find a at this point, so I have negative 84 equals negative 12a. And if I divide both sides by negative 12, I get a is 7. Now I know that z equals 7xy. So if I want to calculate what z is when x is 5 and y is 2, I get 7 times 5 times 2, which is 70. That's pretty non-threatening math, if I should say so myself. Okay. So let's take a look at the final page of our notes. On our final page of our notes, we have an example and we have a checkpoint. So The first example we have, let's take a look, and then you know what the checkpoint's going to do. It's going to tell you to do the same thing, so you might want to pay attention here. Write an equation for the relationship. M varies jointly with N, M, P, N, P, and Q. There's always an A. All of these are going to have an A. N, P, Q. Jointly means directly across the board. Unless they say inversely, there's no inversely. R varies inversely with S. A over S. X varies inversely with the cube of Y. X varies inversely, means it's going to be on the bottom, but Y is cubed. And K varies jointly with X and Y and inversely with M. A, X, Y, what's on the bottom? Inversely with M. And T varies directly with U and inversely with W. A is always on the top, notice. AU over W. AU. AU. That AU is like in your science classes, gold, right? AU. That's gold. You guys check out for just a minute and do these checkpoints. Give yourself about a minute to finish those. All right, welcome back. The variable Z varies jointly with X and Y. Z equals A, X, Y, right away. If Z is negative 44, when X is 4 and Y is negative 1, see, I'm multiplying all this stuff together, find Z, or find A is what you're trying to find. So I have negative 44 equals something times negative 4. Well, hopefully some of you guys right now are screaming 11, right? A equals 11. That means Z equals 11xy. And if I plug the 6 and the 3 in there to find Z, 6 times, I end up with Z equals 11 times 6 times 3. Well, 11 times 6 is 66, and 66 times 3 is 198. So Z equals 198. And on this next one, write an equation for the relationship X varies jointly with Y and Z. X varies jointly with Y and Z. And inversely with the square of T over T squared. There you go. All right, great job. Good luck on your assignment tomorrow. I hope you enjoyed the notes. Let me give you one last flip there, huh? How about that? All right, let's get to it.